difference of squares. Dots, so it says dots. That just means difference of two squares. Sorry, I don't know why I forgot to put that in there. So it's the difference of two squares. And when I say squares, I mean perfect square numbers. Okay, so first things we're going to talk about is what are perfect square numbers. So if you know, look, I have some here. What makes these perfect square numbers? Not quite.
They're square numbers.
They're squared. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. So on and so forth. Right? So what is 7 squared? 8 squared? 9 squared? And so on and so forth. Okay? I don't expect y'all to memorize all the perfect squares, but you can find them in your calculator. So if you're given a number and you don't know if it's a perfect square, you can do second x squared, so you get the square root. And so like yesterday, we got the number 96 at one point to see if it was factorable. Well, see how it gave me a decimal? That's why I know it's not a perfect square. If I type a perfect square under a square root, I get a whole number. Okay, and 10 squared would give me 100. That's why that's a perfect square. Okay, so that's how you can figure it out in your calculator. So the difference of two squares formula is a squared minus b squared equals a minus b times a plus b. Okay? We're going to kind of talk about what this means here in just a second. So how do we know when we can solve using difference of squares? There's a couple things. It must be subtraction. No addition. Okay? What am I writing? Both terms must be perfect squares. Okay? B equals 0. No b term, which I'll explain what that exactly means here in just a second. And I also want you to realize if there's any exponents, I don't know why I wrote any exponents. If exponents are even, it equals a perfect square. So x squared, 2 is even, so x squared is a perfect square. X to the 4th power, 4 is even, therefore it's a perfect square, so on and so forth, okay? X to the 3rd power is not a perfect square because it's an odd exponent, okay? So that's what I meant by that. Exponents are even, that means it's a perfect square. Okay, now one thing you always need to check is if there's a GCF. So, y'all, you still need to make sure it's in order, and you still need to check for GCFs. Those of you online, your cameras need to be on if you want attendance credit today. Okay, so those are the two things that I've taught y'all. Every piece of factoring, you have to check order, you have to check GCFs. That's still in effect. Okay, so let's look at our examples. Okay, I want you to realize that we could technically do the snowflake here. We would use b as 0, and we could do all that work. Okay, I'll show you. We could do a equals b equals c. That's an equal sign. Okay, 1, 0, negative 81. You don't have to write this down. What multiplies to give you negative 81 but adds to give you 0? Negative 9 and positive 9. While I know that this one was pretty quick and simple to do in your snowflake, sometimes you have numbers for a other than 1, and it makes your number on top really, really big, which makes these really, really hard to find. Okay? That's why I don't recommend using the snowflake for difference of squares. While yes, it was easy on this one, and it's totally possible on all of them, it makes it 10 times harder when you get to problems like 5. Okay, if you take out the GCF, you're going to have 9 and 25, but then you'll multiply those, and that's a big old number on the top of your snowflake. Okay? So don't do the snowflake on these. Follow your formula. Okay, so a squared, isn't that just a times a? And negative b squared is negative b times positive b? Well, look, a, negative b, positive b. Okay, all it's doing is breaking apart your perfect square and putting it in the front and the back. The reason there's no b term is because one's negative, one's positive, and they're exactly the same. What happens if something's positive and negative and exactly the same? It cancels. The b term is there, it just canceled. Okay? So that's why this works. So what times what gives you m squared? And what times what gives you negative 81? Negative 9 and positive 9. So your answer is m minus 9, m plus 9. Okay, on this one, it's in order. There's no GCF. What times what gives me 4c squared? It has to be the same. 2c times 2c. And what times what gives me 25? So negative 5 times positive 5. So I end up with 2c minus 5, 2c plus 5. Randall, you close the door for me, please. Any questions with that so far? Okay, so now let's look at number 9. Number 3. It has a 9 in the front. What is the GCF for that one? There is a GCF. What goes into 9 and 36? So here's my recommendation. What's the smallest coefficient, 9 or 36? 9. Does 9 go into 36? Yes. So 9 is your GCF. Okay? Now, this has x, y, and this has z, so they don't have letters in common, so we're just going to take out a 9. And I'm going to put it over here so I remember that it's part of my answer still. And I don't forget about it. I'm going to divide it out. And I get x squared, y squared, minus, what's 36 divided by 9? Now, do I still have a perfect square minus a perfect square? Yeah. Okay, what times what gives you x squared, y squared? But we're going to separate it. So xy times xy, because remember, they need to be the same, because that's what makes the b term cancel. And then what times what gives us negative 4z squared? Has to be the same. Okay, so when I fill in my parentheses, I get xy minus 2z, xy plus 2z. Okay, look at number 4. What do we do? Check for a GCF. Does it have a GCF? It does not. Okay, so what do I do? What's in the middle? A plus sign. So can we do this method? No, what's the first thing I wrote? Must be subtraction. So can we do this method? No, there's no GCF. It's not 3 terms, so we can't factor it using the snowflake. There's no grouping. So y'all, this is prime. Okay? Because there's no 2 things that could multiply to create this. Think about what a prime number is. What's a prime number? Anybody?
4.
No. 5. Why is 4 not prime? Because 2 times 2. So what did you say? What did you... Huh? What number did you say was prime? 5. Okay, why is 5 prime? Because the only thing that multiplies it is 1 times itself, right? There's no other numbers that go into 5. That's this. The only thing that we could possibly take out of this or multiply something by is 1. Therefore, it's prime. There's nothing we can do with it. Okay, look at number 5. Is it in order? Well, 2, 4, 6, 2, 4, 6, so order doesn't matter. Does it have a GCF? Yes. Okay, well, 36 doesn't go into 100, but they're both even. So I know they have a number GCF. Okay, so does 2 go into both of them?
No.
Yes. Does 4 go into both of them?
No.
Yes. Does anything bigger than 4 go into both of them? No. Now, if you took out the wrong GCF, you'll see that there's still a GCF whenever you take it out. Okay? So if there's still one, that means you can take that out too. Okay? So here the GCF is 4. What letter do they have in common? D what? Yeah, they both have D squared. So we're going to take all of that out. Okay, so when I divide by 4D squared, 36 divided by 4 is 9. D squareds cancel, and I'm left with G squared, H squared. Negative 100 divided by 4 is negative 25. D squareds cancel, I'm left with A squared, C squared. Now, is this still a perfect square minus a perfect square? All my exponents are positive, so I know my variables are perfect squares. 9 and 25 are also perfect squares. So yes, it is a perfect square minus a perfect square, so we can keep going. What times what gives you 9g squared h squared? Well, what times what gives you 9? 3. And then it's just gh and gh. Okay, negative 25 is going to be negative 5 and positive 5 with AC. I just separated the perfect squares from those two things and then separated them. 1 plus, 1 minus. Okay, last one, number 6. It's in order. There's no GCF. Now, it has a positive exponent. I mean, not a positive. Even. Has an even exponent, so it's a perfect exponent. Is 256 a perfect square? Okay, if you're like me, I had no idea this morning. Y'all, I don't have perfect squares memorized. Okay, so I came here, and I did 256. So it's 16 times 16. So I know this is going to be positive 16 and negative 16. But what times what gives you x to the 4th power? That's the same. X squared, x squared. Any questions with that? Okay, there are 3 more I want to go over with you on your practice, which is nice because that's me doing 3 of your practice problems with you. Just because they are a little different and they weren't in your notes, and so I want you to be able to see that. So we're going to start with number 5. Okay, first things first, they're in order. 5, 6, 7, 8, 3, 4, 5, 6, 7, 8. So they're both factors of, degrees of 8. So they're in order. Is there a GCF? What do they have? Do they have something in common? Yeah, what do they both have? They both have x's and y's. But remember, we need to take out the greatest common. So not just one x and one y, but how many x's and y's can we take out? Yeah, because this one has 5 x's, this one has 3 x's, so we can take 3 away from both of them. And same concept with the y's. When I take that out, I'm left with x squared, because 5 minus 3 is 2, and the y cubes cancel, minus x cubes cancel, 5 minus 3 is 2. Now, don't forget to put your GCF on your answer line, because that's still part of your answer. Yes, we took it out, but it's still a factor. Okay? Now, is this a perfect square minus a perfect square? Yeah, because x times x and y times y. So we get x minus y, x plus y. There's your answer. Does that make sense? Why did I put an x there? Sorry, y'all. Any questions with that one? So it didn't look like it had a it didn't look like you could factor it using this method until you took the GCF out. That's going to be true for a lot of these. Okay? Look at number 6. It took me a minute to decide which one. Okay, what's wrong with it? Right away.
121.
121 is a perfect square. Order, is that what you said? Yeah, order's wrong. Okay, higher variable has to be first. This is a variable 2, this is, an exponent of 2, this has an exponent of 0 for your variable. Okay, a degree. So we're going to write negative 4x squared, and this is a positive 121. Now, does 4x squared and 121 have a GCF? They actually don't. Okay, because the only thing that can go into 4 is 1, 2, and 4, and none of those go into 121. Okay, so, but am I supposed to have a negative at the front?
No.
So I have to take that negative out. And when I take it out, I have 4x squared. It became positive, right? It's like dividing by negative 1 minus 121. Now is it a perfect square minus a perfect square? Yes. So don't forget to put my negative back in front. What times what gives me 4x squared?
2x squared.
So 2x and 2x. And what times what gives me negative 121? Negative 11 and positive 11. Anytime there's a negative at the front, you have to take it out. Okay? Okay, now look at number 20. Last one I'm going to help you with. Unless, obviously if y'all ask questions, I'll still help you. You're not completely on your own after this. Okay, this is like those ones yesterday where we took the ugly out and then we put it back in the end, right? But it's not worth doing all that on this. Because isn't this a perfect square because the whole thing's squared? So what times what equals that? Well, just x minus 3 times x minus 3, right? X minus 3 times x minus 3 is x minus 3 squared? Okay. What times what gives you negative 25?
Negative 5 and positive 5.
Negative 5 and positive 5. So when I write this, I get x minus 3 minus 5, x minus 3 plus 5. Can I simplify those? Yeah. What's negative 3 minus 5? And what's negative 3 plus 5? There's your answer. So don't let those throw you off. Okay?